there's modified distribution method. We also call it as MODI method, right? It's also called as UV method, right? So in examination, you may get a name of these sorts like modified distribution, MODI method, or a UV method, right? So now what we are going to do is we are going to see this method, and this method is far better than your stepping stone method. Now, when last practical session we have seen and understood the stepping stone method, and you would have you all would agree with me that this method is a time consuming method, and there are a lot of calculations that are involved. So what we are going to do is that we are going to focus upon the minimization of the steps, and minimization of the calculation as well, right? So some sort of calculation, no magic is going to happen, right? So some sort of calculation and some part of some steps will be there, but definitely the time required will be less. Now, so this particular method is now used for checking the optimality. Now we'll be starting with the VAM solution. I'm hoping that the shared screen is visible to you, and what I'm writing is also visible. So the VAM solution that we obtained for the milk problem, right? So milk problem we have completed with the stepping stone method, right? So now I'm again starting with the initial basic feasible solution that we have got with the VAM solution or VAM method. So the VAM solution that we they got, we had 4 distribution centers. 1, 2, 3, 4, and we had 3 sources. Right, and there was some supply constraint, and as well there was some demand constraint. So the unit cost that we had, I'm going to write here. So I think this was the VAM solution that we got, and we are going to proceed with this initial basic feasible solution. So what we are going to do is, from this initial feasible basic solution, we are going to move towards the optimal solution. Now, we already know when we try to check the optimality, what we'll have to do is we'll have to see whether this solution is a degenerate solution or not. So how to check with the degeneracy? We have already seen the number of allocations that we have is how many? The number of allocations is 1, 2, 3, 4, 5, 6. And m plus n minus 1 is also 6. So these are matching, hence we are going to proceed, right? Now when we are going to proceed, what we are going to do differently here is that now we are going to allocate some random numbers, right? Some random values, but based on the calculations, right? So what we are going to do is 1, 2, 3, 4, 1, 2, and 3. So we had the solution. I'm writing here it again for a better understanding, so that I don't make any mistake, or there is no rough work that we have to do here, right? So this was your demand, and this is the supply that we had, right? So these are the sources, these are the allocations, right? Now what we are going to do is we are going to allocate u and v values, right? So this u value that we have here upon u and v values are to be allocated. So now what we are going to do for the rows, we are going to consider u. So here it will be u1, here it will be u2, and here it will be u3, So for first row it will be u1, for second row it will be u2, and for third row it will be u3. Similarly here for DC centers, for the distribution centers, we are going to write v1, v2, v3 and v4. So we are also going to find out these values of u1, u2, u3, v1, v2, v3 and v4. So now how to find out these values, right? Now what we are going to do, we have a we have this formula, right? So I'm just changing the page. For all allocated cells, right? For all allocated cells, your ui plus vi is equal to Cij, right? So for ui plus vj is equal to Cij, right? So we are going to use this particular formula into that respect, and we are going to find out these values, right? Now we have to find out v1, v2, v3 and v4, and we have to find out u1, u2 and u3. So based on the the same solution, 71061 5815 9 361 here it is 1 and 5. So now what we are going to do is, for all allocated cells, so which are the allocated cells? This is the allocated cell, 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 and this is the allocated cell. So what we can write for all this, we can write that for first allocated cell, like, so u1 plus v1, right? So this u1 plus v1 is equal to what? It is equal to 2, right? So this is equal to 2. So this formula we are repeating, right? So we are going to just put this values in this equation. Ui plus vj is equal to Cij. So what I have written is u1 plus v1 is equal to 2, right? Similarly for the next cell, I can write u1 plus v2 is equal to 3, right? For the next allocated cell in row 2, I can write u2 plus v4 is equal to 1. For the next allocated cell in row 3, I can write mu3 plus v1 is equal to 5, right? I can write mu3 plus v3 is equal to 15, and lastly I can write u3 plus v4 is equal to 9, right? Now I have to find out, the values of u1, u2, u3, v1, v2, v3 and v4. But here you can see that how many unknowns I have. I have 1, 2, 3, 4, 5, 6 unknowns, and again, particularly I have 7. I have 6 equations and 7 unknowns, right? So particularly this is not this is not done. I should have some value. So what we are going to do, so to make easy for us, for solving, what we are going to do, we are going to put v1 is equal to 0. Put v1 is equal to 0, right? So we will be writing the value of v1 directly here. So v1 is equal to 0. Now, in all those equations where we have v1 value, so for this, for example, this equation and this equation, we have a v1 value, right? So we can get the value of u1 and u3 directly. So therefore, the value of u1 will be equal to what? It will be 2. Right? Similarly, here mu3 plus v1 is equal to 5. So in this equation, if I put v1 is equal to 0, I'll be getting mu3 is equal to 5. Easy, right? So now that I have got u1 and u3 values, right, I can find out some different value. Now I can put u1 value in this equation and I can find out the value of v2. So now here v2 is equal to what? v2 is equal to 3 minus 2. That will be equal to 1. Right? Similarly, I got a u3 value. So I can put u3 value in these two equations. So now I can put mu3 is 5. So V3 I'll be getting it as 10, and I'll be getting V4 as 9 minus 5, it will be 4. Now that I have got a V4 value, I can put V4 value in this equation and I can find out what is the value of U2. So now the U2 value will be what? U2, it will be 4, V4 value is 4. So 1 minus 4 will be minus 3, right? So I'll be getting the value of U2 as minus 3. No, I think we have achieved all the values. So let's put down the value properly, right? So now we have got the value of U1. So U1 value is 2. That I'll be writing here. Now we have got the next value of V2. V2 is equal to 1. That I'll be writing here, right? Next value mu2 is equal to minus 3. I will be writing it properly here. It is minus 3. Next I have got U3 value as 5, so I'll be writing it here. V3 value is equal to 10 and V4 value is equal to 4, right? All these values we have got. Now how to proceed towards the optimality, right? So for all allocated cells, we have done Ui plus Vj is equal to Cij, right? Now what we are going to do is we are going to check, in similar, in stepping stone, what we have did, the philosophy was, now, okay, we have got some initial basic feasible solution, but what if I allocate some value in unallocated cells and check whether the, after allocation, whether the cost is getting reduced or not, right? So same we are going to do here. We are going to put, we are going to put some value in the unallocated cell, and after putting that value, we are going to see whether the cost is going to get reduced or not, right? But here what is the beauty here? We are not going to test every unallocated cell. In stepping stone method, what we did was, right? So I'm writing here, in stepping stone method, we tested every cell, right? Every unallocated cell by putting some allocation, and then we did this cell evaluation. And if in cell evaluation, if we got negative sign in that particular cell, we were going to allocate we were going to do the allocation, and we are going to get the next feasible solution. But here what we have, this particular method, though it is using the philosophy of stepping stone method, but it minimizes the effort that we are going to do, right? So here what we are going to do, we are not going to test every cell. What we are going to do is we are going to test every cell, but with help of some formula, right? So for here we have done, for all allocated cells, we have used this particular formula. So for all unallocated cells, there is a different formula. We are going to find out the value of Pij. Pij is nothing but the penalty, in that unallocated, for penalty for unallocated cell. So it is equal to Cij minus Ui plus Vj. So this is the formula to find out, penalty across every unallocated cell. Don't get confused. For all allocated cell, the formula is very simple here, and for all unallocated cell, here we have this formula. So let's find out the penalties for all unallocated cells. So which are all unallocated cells? This particular is unallocated cell, this is unallocated cell, this is an unallocated cell, lastly we have this as unallocated cell. All the star marked cells are the unallocated cells. Now first cell that we have unallocated is which one? It is P13, right? So it is cell 13, so I'll be writing the P13 value. So what is a Cij there? The value of Cij is 7 minus what is the U1, what is the Ui and Vj values associated. So for P13, we are going to refer U1 and V3, right? So U1 and V3 addition. So here you can see, V3, it is 10 plus 2, that is 12, right? So now what we are going to do, 7 minus, okay, what was the Okay, why I've written 7? Okay, it is not 7. For P13 it is 11, right? So Pij, so what we are going to do is Pij for 13 is equal to 11 minus 10 plus 2, that is 12. So it is equal to minus 1, right? Similarly, we are going to find out P14. P14 is 7 minus this 2 plus 4, right? So 4 plus 2 is 6, 7 minus 6 is 2. So 7 minus 6 is 1, sorry, right? Nextly we have P, no, we have P21. In P21 we have 1 minus 3 plus 0. So minus 3 plus 0 is minus 3, and no, it is a negative sign, so it will be 1 plus 4. And what will be the value here? Next, yeah, P21. It is 1 plus 3, and 1 plus 3 will have a value of 4, right? So for next cell, what we have, it is no P21, P22, sorry, P22. What we'll be writing, it is 0 minus 3 plus 1 is, minus 3 plus 1 is minus 2, right? Minus 2 will become plus 2, and 0 plus 2 will be getting the value as 2, right? So next cell that we have is P23. So you have minus 3 plus 10, so that comes out to be 7, and 6 minus 7 will be equal to minus 1. Similarly, last cell that we have unallocated is P32. Here we have 5 plus 1 is 6, and 8 minus 6 is 2, right? So these are all the penalties that we have got. The understanding is same, right? So what is the understanding? What is the basic understanding that we have is, for stepping stone, negative sign suggests improvement can be done in that cell. Improvement or improvement in solution is possible if allocation done in that cell, right? So here particularly we are now we have got this particular solution as this solution is not an optimal solution, and we have to iterate towards the we have to iterate towards the optimal solution. Now you can see the difference. In stepping stone method, we a lot of time was consumed. We have to form a loop. After loop formation, particularly we were deciding on the basis of on the positive, alternate positive and negative and signs. We were doing some addition, subtraction, and then we were getting the penalty. But here we have got the penalty with a very simple formula, and the time that we have got is now almost negligible. So if you compare the time, that particular we required 5 minutes to attend all this particular step. Here it was like only 30 seconds or 1 minute. We completely did this particular step. Now what is here? We have got P13 and P13, and which cell is there? P23. Here we have got the negative sign, and similar philosophy, right? So a cell which is having a number with most higher number with negative sign, we are going to allocate there. But unfortunately, what has happened here? We have got a tie. We have got -1 here and -1 here. So what we can do is now we'll have to solve this tie. How we are going to solve this particular tie? Yesterday only we have seen how to solve this particular tie. We'll have to consider where the maximum allocation can be done. So which are these cells? Let's see in which where we can do the maximum allocation. In P13, right? In P13, if we have to do the maximum, we have to consider this particular cell. So for that particular cell, we'll have to do what? We'll have to form a loop. So which is that loop? So this is this loop. So it will be it will be plus, it will be minus, it will be plus, and it will be minus. So what is the maximum allocation that I can do is this particular one only, right? So one will this particular 1 will shift here, because here it is written minus, no, so this particular 1 will shift here, and the maximum allocation that I can do is 1, right? Similarly, they are saying that in P23 also the allocation can be done. So in this particular cell, so what is the cell formation here? Again, you can check out the loop formation is like this. So again, it will be plus, it will be minus, it will be plus, and it will be minus here, right? So here again we'll have to do, so I'll have to do plus, बट आई हैव टू रिड्यूस दिस. सो माइनस में कितना है यहाँ पे, एक तो यहाँ पे माइनस है और यहाँ पे माइनस है, तो 3 तो मैं माइनस नहीं कर सकता, बराबर, तो यहाँ पे मुझे एक ही माइनस करना पड़ेगा. तो यहाँ पे मैक्सिमम एलोकेशन भी क्या है, एक ही कर सकते हैं हम लोग. तो यहाँ पे एक द मैक्सिमम एलोकेशन दैट वी कैन डू इज 1 ईयर, एंड सिमिलरली द मैक्सिमम एलोकेशन वी कैन डू इज 1 ईयर. सो अगेन देयर इज टाइम, right? And what we are going to do again, if there is a tie, we have to consider the arbitrary cell. No, the allocation is to be done in any of the arbitrary cells. So what we'll be doing is, now let's do allocation. Let's do the allocation where we are going to do the allocation in P. No, which one? Let's take the first one only, P13 directly. So if we do the allocation in P13, how this will get, I'm just we'll continue the lecture more for 5 minutes and then we'll be stopping up. Lecture will continue till, no, we have more time. The lecture is till 10:50. Okay, 1 2 3 4, so the 2 3 11 7 1 0 6 1, it is 5 8 15 and 9. So this is the allocation that we had was here. Then it was, according to the VAM solution only, we had 1 and 5 here. So it was 1 and 5 here, and it was 6 and 3 and 1 here. Okay, sorry, let's do allocation in P. Which cell we are going to consider for the allocation. We are going to consider this cell P, or cell 1 3 for the allocation. Right, the VAM solution that we had was 2 3 11 7 1 0 6 1 5 8 15 9, 5 8 15 and 9. So 6 3 1, here it is 1 5, and here it was 1. So we have to do the allocation in this particular cell. So what we are going to do is, we are going to form a loop for this particular cell. It is very simple. This will go down, this will go down, up here, this will go up, and here it will go like this. So we have to do the allocation here, plus, here it is minus, here it is plus, and here it is minus. So to satisfy this particular constraint, we'll have to, here we have an allocation of 1. So we'll also have to satisfy the constraint. So in this particular cell, we'll have to put 1 only. So how this particular solution, therefore new solution obtained is, the new solution that we are going to obtain is like this. Is 1 2 3 4 1 2 3, it is 2 3 11 7 1 0 6 1 5 8 15 9, right? So there will be some changes that will be taking place. So previously here there was some allocation in this particular cell, but now it will going to be 0. 5 will remain same, and here it will come now 1. So here now this was 3. So 3 minus 1 will come here 2, right? So here it was plus, right? So 6 plus 1 will come here 7, right? And this is the previous. So here you can see, so 7 plus 2 plus 1 is 10, 1, 5 plus 1 is 6. So the our supply is matching. Here, what we have, 7 plus 0 is 7, 7, 5, 3, 2, right? So all the demand and supply constraints are also matching. So this is how the new solution that we have got, but we'll have to check whether this is optimal or not. So we'll have to check the optimality. So check the optimality, again we are going to check it by UV method only. So number of allocations, here we have how many? The number of allocations are 1, 2, 3, 4, 5 and 6. 6, m plus n minus 1 is equal to 6. Hence we are going to proceed. Right, so we are going to proceed and again going to check the optimality. So how the optimality will be checked? It will be done by UV method. So I'll be writing the obtained solution on the new page so that we get ample space to understand the procedure. One, two, three, four, 1, 2, 3, right? So it will be V1 here, it will be V2 here, it will be V3 here, and it will be V4 here, right? It will be U1 here, U2 here, U3 here. So the allocations that we are now new. So it is 2, 3, 11, 7. It will be 1, 0, 6, 1, 5, 8, 15, 9. So here we have 7, 2, 1. It is 1 here. So it is 5 and 1 here. Right? So we already have for all allocated cells. Right? What we have the formula? Cij is equal to Ui plus Vj. So for all allocated cells, we are going to write. So these are the allocated cells: 1, 2, 3, 4, 5, and 6. So what we can write? U1 plus V2 is equal to 3. U1 plus V3 is equal to 11. Right? Nextly, U2 plus V4 is equal to 1. U3 plus V1 is equal to 5. U3 plus V3 is equal to 15. U3 plus V4 is equal to 9. See, all these are the for all allocated equations we have got 6, 1, 2, 3, 4, 5, 6. 6 equations, right? So same thing, put V1 is equal to 0. Right? So if we put V1 is equal to 0, I can find out the value of mu3 as 5. When I get value of mu3 so as 5, so I can get V3 as 10, right? And even I can get V4 as how much? 4, right? So same values, same obtained values we are going to put upward. V4 we have got 4, so here U2 U2 is equal to how much? 1 minus 4, and that will be minus 3. Right? Same V3 value I've got here. So V3 value we can put 10. So U1 is equal to 1. And lastly, we can find out what is the value of V2. V2 will be equal to what? It will be 3 minus 1. It will be equal to. So all these values we have got, will be substituting the values. U1 value is 1. U2 value is minus 3. We have U3 value as U3 have we found out u3? Yeah, u3 value is 5, v1 value is 0, v2 value is 2, v3 value is 10, and v4 value is 4, right? So I'm hoping that you have understood at least this particular step. So here we have u3 as 5, v3 as 10, v4 as 4, u2 as -3, u1 as 1, and v2 as 2. So for all unallocated cell, what we are going to do is, for all unallocated cell, we are going to find out the penalty by a formula. Pij is equal to Cij minus ui plus vj, right? So for finding out the value which are the unallocated cell, you can see. So here this is the unallocated cell P11. So what is the number? You can do the calculation in mind. So we have 2 minus 1, that is coming out to be 1. Nextly, if we consider P next cell, that is P14. P14 we have 1 plus 4 is equal to 5, and 7 minus 5 is equal to 2, right? Next allocated cell is this. So we have P 21 is equal to -3 plus 0 is 0, 1 plus 3 is equal to 4, right? So P22, this cell, -3 plus 2 is -1, 0 plus 1 here is 1. P23, this cell, so -3 plus 10 is 7, and we have 6 minus 7 as -1. Nextly, we have this cell which is which is P32. So P32 is equal to 5 plus 2 is 7, and 8 minus 7 is 1, right? So here also, if you see, we have got -1 here in this cell. So the obtained solution is not optimal, right? And iterate further by doing allocation. We have only one cell, that is 2, 3, right? So in 2, 3 we have to do the allocation. So if we are doing the allocation in P2, 3, so I'm going to write the the previous solution for which we are going to do the iteration, and not the VAM solution. Do not write the VAM solution here. Again, you will be in big trouble, or you will be not getting the answer only. So 2, 3, 11, 7, 1, 0, 6, 1. So we have 5, 8, 15, 9. So this is 7, 2, 1, 5, and 1. So in which cell they are telling us to do the allocation? Yeah, so the cell is 2, 3. So this is the cell. The cell is P23. So if I have to do the allocation here, the loop that I should form is like this. So it will be plus, it will be minus, it will be plus, and it will be minus. Therefore, new solution obtained. New solution obtained will look like this. New solution obtained is 2, 3, 11, 7. Here it won't be any change. 1, 0, 6, 1, 5, 8, 15, and 9. So here it will be coming 1. Here it will be 0, right? Here it is 1. So it will be 2, and here it will be 1. So this is 7 here. So if you see the constraint 6, 1, 10 getting satisfied, 7, 5, 3, and 2 also getting satisfied. So this is the new solution that we have, and now we have to check the optimality. Check the optimality. So if you have to check the optimality, number of allocations I'll be finishing this in 2 minutes, because again it will be a problem to again repeat. So let's check the optimality. So the same solution I'll be writing again to avoid the confusion. Right, so it is 2 3 11 7 1061 15 8 sorry 5 8 15 9 5 8 15 9. So according to the new solution, we have got the solution as 7 1 2 1 5 and 1 here. So right, so what we have to do is we are now check the optimality by UV method. So you're going to find out U1, U2, U3 values, V1, V2, V3, and V4 values. Right. So for all allocated cells, Cij is equal to Ui plus Vj. So you can do the for all allocated cells. So this, and this are the allocated. So you will be writing U1 plus V2 is equal to 3, U1 plus V3 is equal to 11, U2 plus V3 is equal to 6, right? No, U3 plus V1 is equal to 5, U3 plus V3 is equal to 15, and lastly we have U3 plus V4 is equal to 9. Right. So for all unallocated cells, you have Pij is equal to Cij minus Ui plus Vj. So that we are going to do. So for all unallocated cells, so this is P11. Okay, we have to find out, put V1 is equal to 0, right? So put V1 is equal to 0, U3 is equal to 5, right? So if U3 is equal to 5, V3 is equal to 10, and V4 is equal to 4. V4 is equal to 4, right? So substituting the values of V3 here and above. So V3 here we will be getting it as 10, right? So V3 we get it as 10, and U2 is equal to 6 minus 10, so it will be minus 4, right? So again we can use V3 here 10, so U1 is equal to 1 here, right? If U1 is equal to 1, V2 is equal to 2. So we can put the value V2 is equal to 2, V3 is equal to 10, and V4 is equal to 4. U1 is equal to 1, U2 is equal to minus 4, and U3 is equal to 5. Right? So you can find out what is P11 now. So P11 will be 1 plus 0 is 1, 2 minus 1 is 1. So nextly we have P14, 1 plus 4 is 5, and 7 minus 5 is 2. Right? Nextly we have P2 1. So here minus 4 plus 0 is 0, and 1 plus 4 comes out to be 5. Right? So P22 we have minus 4 plus 2 is minus 2, 0 plus 2 comes out to be 2. For P24 we have minus 4 plus 4 is 0, and 1 minus 0 comes out to be 1. Lastly we have P32, and it is 5 plus 2 is 7, and 8 minus 7 is 1. So here all values are positive, and we get the optimal solution for this problem.